Now we will see uniform circular motion. Definition of uniform circular motion. When an object follows a circular path at a constant speed, the motion of the object is called uniform circular motion. So when an object moves in a circular path at constant speed, the motion is called uniform circular motion because the object moves in a circular path. You see, here the object moves in a circular path. Initially the object is at point P. This is the center of the circular path. C is the center. P is the position vector. P is the position. The object is at point P. The position vector with respect to center is R vector. The object moves in the circular path. The velocity of the object is tangential to the point. It is tangential. The velocity is tangential to the point. Velocity of the object is tangential to the point. Velocity v vector is the velocity vector of the object. It is in this direction. As the object moves along the circle, the direction of velocity changes, but the speed remains constant. The magnitude remains constant, but the direction changes. It is in this direction, then in this direction, in this direction. Therefore, the velocity of the object at point P dash is v dash vector. The position of the object at point P dash is R dash vector with respect to center C. Now here, when the object moves from P to P dash, position of the object is R vector initially, then when it is at P dash, it is R dash vector. Therefore, according to the triangle law of vector addition, R dash vector is R vector plus del R vector. Del R vector is the displacement. This del R vector is the displacement of the object. Right. So this is the, therefore R dash vector is equal to R vector plus del R vector. The del theta is the angle subtended by the object as it moves in the circular path. Let the object take del t time to reach the point P dash from P. Therefore, the time taken by the object is del t. Del theta is the angle subtended. Now, let us draw the velocity triangle. This is the velocity triangle. So here this is the velocity v vector. I have drawn velocity vector v vector. This is velocity vector v dash vector. I have drawn velocity vector v dash vector. Therefore, v dash vector is equal to v vector plus del v vector. Del v vector is the change in velocity of the vector. Therefore, the acceleration can be written as average acceleration is equal to del v vector by del t, which we have discussed already. Here R vector is the position vector of the object at point P. Already I told you. And R dash vector is the position vector of the object at point P dash. Therefore, average acceleration A vector equal to del V vector divided by del T. So this is according to the calculus. Magnitude of this is the average acceleration. Then instantaneous acceleration is del T tends to 0 because del T is very small. As del T tends to 0, del theta tends to 0. Therefore, we can write limit del T tends to 0 modulus of del V vector divided by del T. This is the modulus of that average instantaneous acceleration. Right. Now, triangle CPP dash is similar to triangle GHL. You see that triangle CPP dash. This triangle is similar to triangle GHL. Therefore, this del theta is equal to here also this is del theta. Therefore, according to the triangle law property, ratio of the sides or corresponding sides are equal. Therefore, del V, here this is del V. Del V divided by V is equal to there del R divided by R. Del V divided by V equal to del R by r. Therefore, del V equal to, take V to the right side, V into del r by r. R is nothing but magnitude r. R is equal to radius of the circular path. R is the radius of the circular path. Therefore, the instantaneous acceleration, this is the average acceleration, this is instantaneous, right? So let me write this instantaneous acceleration, right? This is limit del t tends to 0, right? So here del t tends to 0, right? V del V, this substitute, this is the del V equal to V into del R by R, right? Therefore, substitute here, this is del V, this is del V, substitute this value here. Therefore, I have substituted limit del t tends to 0, because del V is this, substitute this value here. Therefore, magnitude of acceleration A vector equal to limit del t tends to 0, V by R del R by del T, right? When we substitute here, it becomes del R by del T. Here I am substituting del V value here in this equation. Therefore, take V by R outside. V by R magnitude of acceleration, that is A, is equal to V by R into limit del T tends to 0 del R by del T. Now let us see A is equal to acceleration, instantaneous acceleration. A is equal to V by R, limit del t tends to 0 del R by R. Del R, limit this value, limit del t tends to 0 del R by R is equal to V, velocity, right? That is speed here. So V into V, V by R into V square by R. So the acceleration AC is equal to V square by R. This is called the centripetal acceleration. This is called this acceleration is called centripetal acceleration. This acceleration it is directed towards the center. This is the centripetal acceleration which is directed towards the center of the circular path. This is called centripetal acceleration. AC is equal to V square by R, centripetal acceleration in a uniform circular motion. This is directed towards the center of the circular path.